Hello everybody! Today I'm going to talk to you about a course called Math208. It's a challenging and intellectually stimulating course. This class will prepare you for the real world by showing you how to learn a topic and then apply it to a real world situation. In this class there are many different subjects. Some of the ones that I will cover today are linear functions, system of equation questions, and matrices. There are many other aspects to this course. However, I will just be discussing the first 3 chapters. To begin this video, I will start with Chapter 1, Section 1, which is linear functions. To begin this section, we will talk about linear functions. The equation for a linear function is defined to be y equals mx plus b, where m is the slope, or rise over run, and b is the y-intercept. Sometimes we refer to this equation as fx equals mx plus b. We do this so that we can substitute x into the problem. For example, if we have a slope of 8 and a y-intercept of 4, it's called fx equals 8x plus 4. But then, if we want to substitute a number in for x, we would do this. If x equals 2, we would put 2 into the equation and in place of x. So f equals 2 equals x times 2 plus 4. So f to the 2 equals 20. Now we're going to apply this to a real-life situation. So say we get this problem. Jamie works in the car selling industry. When she sells 5 cars, she receives $2,500. However, when she sells 8 cars, she receives $3,400. Let's find a linear equation for the amount of money that Jamie makes on these cars. So we're going to put this into Excel. So first what we're going to do is we're going to write our x, our y, our m, which we know is our slope, and our b, which is our y-intercept. And I labeled these here. X stands for our number of cars, y stands for our cost, m is our rise over run, which we know is y2 minus y1 over x2 minus x1. And b is our y-intercept, which to get that we do y minus m times x. So first we take these numbers that we got from our problem here, and it says she sells 5 cars and she receives $2,500. And then it says she sells 8 cars and receives $3,400. So we put in the 5 as her number of cars and the $2,500 as the cost, and then we do the same thing with the other numbers. Now to get this, I'm going to click on this spot underneath so that I could show you guys how to do it. You have to put equal to, then a parenthesis, and then you're going to take the y2, which is this, and subtract y1, which is this number, and then put another parenthesis. Then you divide it by parenthesis this number minus this number, and then we put another parenthesis and hit enter, and you see I got the same number there. Now to do this, we do again equal sign, and then we're just going to follow this formula. So we do y minus m times x. So we can choose either set of numbers, so I'm going to choose the top. We do y minus, then we do our slope, and then we multiply that to our x value, and we hit enter, and then we get 1,000. So as we know, we do it into y equals mx plus b. So we take our slope that we just got and our y-intercept that we just got, and we stick it into that equation, and we find out that our equation is equal to y equals 300x plus 1,000. After we have learned how to find our slope and our y-intercept, we need to learn how to plug in x values for f of x. So here we have a table, and we are looking to find f of 0. So we go into our table, and we find where our x value equals 0, and then we go to our corresponding f of x value, and it equals 3. Therefore, f of 0 equals 3. Similarly, if we're trying to find f of 4, we go and we find our x value of 4, and then we find that our f of x value is 7. So f of 4 equals 7. To go a step farther, we can do f of 2 minus f of 0. So we go in and we find that f of 2 is equal to 5. And then we find that f of 0 is equal to 3. So we do 5 minus 3 equals 2. So f of 2 minus f of 0 equals 2. We could do the same thing with multiplying them together. So we could do f of 2 times f of negative 2. And we find that f of 2 is 5, f of negative 2 is 1, so 5 times 1 is 5. Sometimes you will get an equation where you have to plug something in for f of x. So here we have fx equals 3x minus 5, and we have to find f of 2. So we plug this into the equation, and we get 3 times 2 minus 5, so our answer is f of 2 equals 1. Sometimes we will get other variables that we have to plug into the equation, such as find f of a. So we put that into the equation, we replace all of the x's with a's. So we get f of a equals 3a minus 5. Sometimes we will get multiple variables that we have to plug into our equation. Here we have f of x plus y. So we plug it in and we get 3 times x plus y minus 5. So when we multiply all that out, we get f of x plus y equals 3x plus 3y minus 5. Another way to find solutions for numbers that are plugged into f of x is to use a graphing calculator. So here I have a TI 83 Plus, and what I'm going to do is I'm going to take my equation, I'm going to hit y equals, and then in y of 1, I'm going to put in my equation. So I put 3x minus 5, and then what I'm going to do is I'm going to hit second graph, and this is going to bring up my table of values. So if I'm looking for f of 2, I go down to where x equals 2, and I look over and I see that my answer would be 1. If I'm looking for a different number, such as f of 5, I would go down to where my x equals 5, and I would find that my solution is 10. And that's how you do it on a graphing calculator. Now we're going to learn about how to sketch a linear function. So here we have the equation y equals 3x plus 6, and we're going to first start by getting the x and the y intercepts. So when y equals 0, that's our x-intercept. So to get this, we set y equal to 0, we plug it into the equation, and we get 0 equals 3x plus 6, and then when we do all the math out, we get x equals negative 2. Then we're going to find the y-intercept, which is when x is equal to 0. So we plug 0 in for x into the equation, we do all the math, and we get y equals 6. So then here we have our y-intercept, and here we have our x-intercept. We're going to plot them on a graph, and then we're just going to sketch a line through them. And that's how to simply sketch a linear function. Now that we have finished Chapter 1, Section 1, we're going to backtrack and define what things we've actually learned. So by the end of this section, we should be able to define what a slope is and what a y-intercept is. And we should be able to apply those concepts into the actual problems. We should also be able to substitute a number, a variable, or any set of variables into an fx equation. Other than that, we should be able to sketch a linear function. Now we are going to move on to Chapter 1, Section 2. So here we have a simple word problem, and it starts off saying, Tom is trying to build a fence for his vegetable garden. In order to do this, he must first figure out how much it will cost to build his fence. He finds that the north and the south sides of the fence will cost him $4 per foot. The east and the west sides, however, will cost him $7 per foot. How much will his fence cost him? So we drew a simple graph, and it just shows his fence, and we realize that x stands for the feet in the fence. So we have the north and the south sides both equal 4x, and then the east and the west sides both equal 7x. So to get the total cost, we would add all of these numbers up, and we come up with a grand total of 22x, which means that it would cost Tom $22 per foot to build his fence. Now we are going to work on a simple word problem involving cost function. So the problem is, a furniture builder has a daily fixed cost of $1,000 and a marginal cost of $2,500 per couch. Now we are going to work on a word problem which involves cost function. So the problem is, a furniture builder has a daily fixed cost of $1,000 and a marginal cost of $2,500 per couch. So we want to find the cost of building a couch in one day. So what we're going to do is we're going to take the format fx equals mx plus b, the linear function equation that we've been using, and we're going to substitute in our values to find our cost function. So m becomes our marginal cost and b becomes our daily fixed cost. So when we plug all that in, we have that our cost function equals 2,500x plus 1,000. Next, it says, on a given day, what is the cost of building 5 couches? So what we're going to do is we're going to take our x value, which stands for the number of couches that we build in a day, and we're going to plug 5 in instead of our x. So we take our function, we plug in 5, we do out the math, and we get that to build 5 couches in one day, it would be $13,500. The next question is, what is the cost of building the 5th couch that day? The cost is $2,500 because that is our marginal cost, which is the cost of the couches that we build that day. Next, it says, what is the variable cost? The variable cost is the marginal cost times the number of couches that we build that day. Therefore, since we're not sure how many couches we're going to build in a day, our variable cost is 2,500x. And that is a simple cost function. Now we are going to do another cost function problem. So what this says is Oswego's college newspaper, the Oswegonian, has a daily fixed cost of $50 in addition. It has a marginal cost of 22 cents a copy, and it sells for 66 cents a copy. So the first question is, what is the cost function? And just like we did in the earlier problem, the cost function is the marginal cost times x plus 50. So our cost function is 0.22 for the 22 cents, x plus 50. Then it says, what is the revenue function? The revenue function is how much each copy sells for times x, which is the number of copies. So we do 0.66x is our revenue function. Then it says, what is the profit function? And as you can see on the right side, I have arranged a table, and this will make it a little easier to organize your data. It says the fixed cost, the marginal cost, the price that the copies sell for, the cost function, the revenue function, and then the profit function. And as you can see in the table, the profit function is equal to the revenue function minus the cost function. So if we think about this, our profit is how much we make in a day minus how much we lose in a day. So our profit function is equal to 0.66x minus 0.22x plus 50. Then it says, what is the profit or loss if we sell 300 copies of the Oswegonian? So what we would do for this is we would take 300 and we would substitute that in for our x value. So we take our profit function, we're going to put 300 in place of all the x's, we do out the math, and then we get an $82 profit. The next question is very important. It's a break-even question. It says how many copies should be sold in order to break even, which what this means is that we don't want to gain any money, we don't want to lose any money, we want to break even at the end. So what we do for this is we're going to take our profit function and we're going to set it equal to 0. So we have 0 equals 0.66x minus 0.22x plus 50. So then when we set that equal to 0 and we do all the math, we get 113.63. So if we just round that, we get 114 copies, which means in order to break even, we should sell 114 copies a day. And that is a cost function. We now have another cost function problem. This problem is called an equilibrium price problem. So it says, the demand for your Nooks in weekly sales is y equals negative 5x plus 900. The selling price is X dollars, and you are prepared to supply y equals 5x minus 600 per week at the price of X dollars. What price should you sell your Nooks for so that there is neither a shortage nor a surplus? So to do this, we could do it by hand, and we could set the demand equal to the supply, and we can solve for X, or we could do it in Excel. So I'm going to choose to do it in Excel, and I laid out here we have our X values, which you could just do it in 50 increments or 100. And then I have our demand, our supply, and then our demand minus our supply, which is our profit function. So we're going to take the demand, to do this, we're going to say equal to, and then we're going to do negative 5 times, then we're going to do our X value, so we click on our X, and then we do plus 900, and we hit enter. Then we're going to do our supply, which is equal to 5 times, we hit our X, minus 600, we hit enter. And then we're going to do our demand, minus our supply, which is equal to, and we just hit our demand, then we do minus supply, and we hit enter. So this is for our X value of 0. We can do it again, the same thing. We could do negative 5 times our X value of 50 plus 900, hit enter. We could do equal to 5 times our X value minus 600, hit enter. And we could do the same thing with our demand minus our supply. We do equal sign, demand minus supply, and hit enter. If we don't want to do it manually, we can drag these over, drag this down, and then we could use this little arrow over here and go all the way down. So then we're going to go down to our full chart over here, which I made earlier. And this shows all the way up to 1,000x. So we're looking for the point where there's no shortage and no surplus, which means that our demand equals our supply, or that our D minus S is equal to 0. So we're going to look for this here. We're going to go through our chart, and we can see as we go down that right here our D minus S equals 0, and also that our demand and our supply are the same number. They're both 150 and X is 150, which means that in order for there to be no shortage and no surplus, we would have to sell 150 Nooks. We have now completed section 1.2. By the end of this section, you should be able to figure out the cost function, the revenue function, and the profit function of a problem, and you should understand what these mean. You should be able to figure out the break-even point of a problem and the equilibrium price in a problem. And you should be able to apply these concepts to different word problems. We will now start section 1.3, and to begin, we're given this table. This table has values for f and values for f of x. Now, we want to find the line that contains these points. So to do that, we first have to find the y-intercept. So we have to find when x is equal to 0. So we go into this chart and we see where it says 0, and then we see that f of x is equal to 8 where it says 0. So that means that the y-intercept is 8. Now we have to find the slope of the equation. So to find the slope, we're going to do rise over run, which is also y2 minus y1 divided by x2 minus x1. So to do this, we're going to come over here, we're going to click this cell, we're going to do equal sign and then parenthesis. Then we're going to go and we're going to pick any y value, so f of x value. So I'm going to take the 8 and then I'm going to do minus the 2, and then we have to close our parentheses and do divided by. Then we have to open new parentheses, and then we have to take the corresponding x values. So we'll do 0 minus -1, close our parentheses, hit enter, and our slope is 6. So since we know this, we could put it into our mx plus b equation, and we get y equals 6x plus 8 is our equation for these points. We may also come across a problem like this. Calculate the slope, if defined, of the straight line through the given pair of points. So we have the points 10 and -7.5, and we have 0 and -1.5. So first we have to find the y-intercept, and to do that we look for the pair where x is equal to 0. So we find that when x is equal to 0, y is -1.5, which makes the y-intercept -1.5. We then look for the slope. So to do this, we have to follow the equation y2 minus y1 divided by x2 minus x1. So we go over to our Excel spreadsheet, we go where it says slope, and we're going to hit equals. We're going to open our parentheses, then we're going to do y2 minus y1, and we're going to close our parentheses and do divided by, open our parentheses again, and do x2 minus x1, close our parentheses, and hit enter. And then we see that our slope is -0.6. So then when we put these numbers into our y equals mx plus b formula, we get y equals -1.5x minus 0.6. We may also come across a problem like this. It says, find a linear equation whose graph is the straight line with the given property. The line goes through the points 0.5 and 2, and it's parallel to the line y equals 4x plus 2. So when we look at this equation, we see that the slope is 4 because it's the number in front of the x. So if it's parallel to this line, it means that it contains the same slope. So we know that our line contains the slope of 4. So then we just need to find the y-intercept. So we introduce this new formula. It's b equals y1 minus m times x1. And that's the formula to get the y-intercept. So we plug in our numbers that we just got. We plug in our y1, our slope, and our x1. And we come up with b equals -7.5. So when we put this into the mx plus b formula, we get y equals 4x minus 7.5. And that is our formula for this problem.
Sometimes we will be introduced to a problem like this and we'll have to apply the same concepts. This problem says, the microwave factory can produce 150 microwaves in a day at a total cost of $10,100, and it can produce 170 microwaves in a day at a total cost of $10,600. What are the company's daily fixed costs? So there are some steps to this problem. First, we have to realize that the numbers within this problem are points on a graph. So we have an x value, a y value, and then we have another x value and another y value. So as we can see from the Excel spreadsheet, we put it right here. If the microwave factory can produce 150 microwaves at a total cost of $10,100, then that's our first x and y value. And then they can produce 170 microwaves at a total cost of $10,600, so that's our second x and y value. So first we need to find the line that these points are on. So we need to find the equation. So we need to first look and find the slope. So to do this, we use the equation that we've been using, y2 minus y1 divided by x2 minus x1. So we're going to put that in right here. We're going to do equal sign, open parentheses, y2 minus y1, close parentheses, divided by open parentheses, x2 minus x1, close parentheses, enter. And then we see that our slope is equal to 25. Then to find our y-intercept, we do the same equation that we've been using, which is b equals y1 minus m times x1. So we do equals 2. We pick any set of points. So we'll do the first one. We do y1 minus parentheses slope times x1, close parentheses, hit enter, and we see that our y-intercept is 6,350. So we make this into our equation using the y equals mx plus b formula. So we see that our equation is y equals 25x plus 6,350. And we know from previous problems that our slope is our marginal cost and our y-intercept is our daily fixed cost. So the question asks us, what are the company's daily fixed costs? So we go to the y-intercept and we find out that our daily fixed costs are $6,350. We may also come across problems like this. The position of a model train in feet along a railroad track is given by the equation s to the t equals 5.5 t plus 10 after t seconds. So we know that the variable t stands for the seconds that the train has been moving along the railroad track. So when we look at the first question, it says, how fast is the train moving? So really all this means is that we're looking at our variable. So in front of our variable is 5.5, which means that our train is moving 5.5 feet per second. Then we look at the second question, and it says, where is the train after 4 seconds? And in order to get this, we know that our t equals our seconds, so we plug 4 in for our t value. We do out the math, and we get 32, which means that after 4 seconds, our train has moved 32 feet along the track. Finally, we go to our last question, and it says, when will it be 44 feet along the track? So to find this, we put in 44 equal to our equation. And then when we do out the math of this, we get t equals 8, which means that when the train is 44 feet along the track, it will have been moving for 8 seconds. We have now finished section 1.3. By the end of this section, you should be very comfortable with linear equations. You should know how to find a linear equation when given any set of points, and you should also be able to manipulate that skill into different types of word problems. So now we will start the final section to this chapter, which is section 1.4. To begin section 1.4, we will start with computing the sum of squares error by hand. So here we have 3 different points. We have 0, 1, 1, 1, and 2, 2, and we're going to put them into a little table. So as you can see, we put in our x values here and our y values here. Then what we did is we put in the next column, which is predicted, which what that means is you take your x value and you add 1 to it. The next column is residual, which is you take your y value and you subtract what you just got here, which is called your y hat from your y value. And then after you get this value, you take it and you square it. So as you can see, that's what we did. We took our x value and we added 1, which gave us 1. Then we took our y value, which is 1, and we subtracted this value, which is 0. And then we took our 0 and squared it, which is still 0. And we did this with this column and this one as well. So therefore, after we're done with all this, we take these 3 numbers and we add them all together, and we come up with a grand total of 2. So our sum of squares is equal to 2. Once you understand how to compute your sum of squares, you need to put it into perspective. So here we have a problem, and it says, we have a data chart for the amount of electricity that is run through a neighborhood every year. So we could see that our data chart is up here, and we have our year, which is 0, 1, 2, 3, 4, and it all starts in the year 2000. So this is 2000, 2001, 2002, 2003, and so on. And then we have the watts of electricity used per year. So in 2000 there was none, in 2001 there was 10, 2002 there was 25, and so forth. So it says we need to find the regression line for this set of data. So what we're going to do is we put our x and our y values into a little chart like this, so that our x and our y values are together. And then we're going to take them and we highlight them, like I'm doing right now. Then we go up to Insert at the top of the page. We go to Scatter, and then we go to the first scatter plot option, which is right here. It'll give us something like this, which is what I started with. Then I'm going to right click on a point, and I'm going to go to Add Trend Line. Okay. So a lot of times with these questions, it'll ask you, is this able to be a linear function? And a lot of times the answer is no. Because if you look here, if we click linear, and then we click close, you can see that this line doesn't really match up with these points. Therefore, it's not a linear function. It has to be a different type of line. So we're going to right click again, say Add Trend Line, and we're going to try a different type of line. So we're going to go with polynomial. And we're also, down here, we're going to click Display Equation in Chart, and we're going to click Display R squared value in chart. Okay, and then we're going to go to Close. And then as you can see, we have our other line. This linear line doesn't mean anything. We have our polynomial line, and it matches up well with our dots. And then we have here, it just gave us our regression line. So we take this regression line, and this is the answer to our problem. Find the regression line, and our regression line is y equals 12.2 x squared minus 14.5x plus 4. We are now finished with Chapter 1, Section 4. By the end of this section, you should know about sum of square errors, and you should know how to get a regression line using Excel. You should also be able to apply these concepts to word problems and real-life situations. So now we have finished Chapter 1. In Chapter 1, they explained a lot about linear functions, cost functions, and sum of square errors. We will now move on to Chapter 2, which is about systems of equations. So Chapter 2 deals a lot with systems of equations. So here we have these two systems of equations. We have x minus y equals 28, and we have x plus y equals 32. And what we're going to try and do is we're going to try and decide what the values are for x and for y that would make these equations true. So there are a lot of different methods that we could use while we do this. I'm going to go over the first one with you. The first thing that you can do is you can substitute in for a variable, which means that we can get x alone, and then once we get x alone, we can go back into our equation and we can put in what x equals as the x value. So let's try it step by step. So we want to get x alone, so we take our first equation, and it's x minus y equals 28. We take our y to the other side and we leave our x. Therefore, we have x equals 28 plus y. So now we know our x value, it's 28 plus y, and we're going to substitute that into our other equation. So we take our equation x plus y equals 32, and instead of writing x, we're going to write 28 plus y equals 32. So when we do all the math out, we get 2y plus 28 equals 32. We subtract 28 from the 32, and then we divide by 2, and then we're going to get y equals 2. So then from there, we're going to put it back into our first equation. So we know our y value, and we have x minus y equals 28. So instead of y, we're going to put 2, and now we're going to solve for x. So once we do the math, we get x equals 30. So our points are 30 and 2. Another way that many people like to go about solving systems of equations is by adding the two equations together. So what we're going to do is we're going to take x minus y equals 28 and x plus y equals 32. And since both of our y's are different signs, our y's are going to cancel out once we add them. And we're going to be left with 2x equals 60, which once we divide the 2, we get x equals 30. So then we're going to take the 30 and we're going to sub it in for our x value into our equation. We're going to solve for y, and we're going to get y equals 2. And then, as you can see, we get the same points, 30 and 2, as our values. Another way to solve for this is by setting both of the equations equal to each other. So we have x minus y equals 28 and x plus y equals 32. But first we need to put one variable behind the equal sign in both of the equations. In other words, we need to have x equals something and then x equals something again. So what we're going to do is we're going to put x on the side of the equal sign. So we're going to first do it with the equation x minus y equals 28. We're going to solve for x, so we get x equals 28 plus y. Then we're going to do it with the equation x plus y equals 32. We're going to solve for x, and we get x equals 32 minus y. Then we're going to get rid of the x's for a minute, and we're going to take both of those equations that we just got, and we're going to set them equal. So we get 32 minus y equals 28 plus y. Then we're going to solve for y, and we get y equals 2. And then again, we're going to substitute it back into our first equation. We put the 2 in for y, we solve for x, and we get x equals 30. And then we have again our points 30 and 2. Now another way that we can go about this, and the final way that I'll talk about, is by using technology. So we're going to use Excel because that's a big part of this course, and we are going to take one of our variables, I picked y, and we are going to put in a bunch of values for it. So let's start new with this. We're going to take y, we're going to start from 0, we put in 0, put in 1, and then, we could just drag down like we do, and we'll get what I got here. We could just keep going as long as we want. Then we are going to take the equations that we got from the last method where we had to solve for x. We want y in these equations. So what we're going to do is we're going to solve for x, and then whatever x is equal to, we're going to take these two equations and put them into Excel. So when we're looking for our y, x equals 28 plus y. And in our other equation, x equals 32 minus y. So we put these two equations in, and then what we're going to do is we're going to actually put these values in. So we say equal to 28, and then we say plus, and we click on our y value. And then we hit enter, and you see that I got the same number. And then once you do that, you can go in here, and you can go like this, and you could drag all these numbers down, and you'll get all the numbers that you need. And then with this one, we do the same thing. We hit equal sign. We do 32 minus, and we click on our y value over here. We hit enter. As you can see, we get the same numbers. We can drag them down if we'd like. Okay, now once we do this, we are going to take all of these columns that we just created, and we are going to highlight them. Okay, so we highlight them. Then we go to insert at the top, and we're going to do a scatter plot again. So we go to the first option here. We're going to do a scatter plot, and it gives us this. So we can add a trend line if we'd like. It's not necessarily necessary, but we could add a trend line if we'd like. So we did linear, and let's do linear again. We'll add another trend line for you. Okay, so now we have both of our lines, and now you can see that they intersect right where we got our solution the last time. If we go and we see where they intersect at 30 and 2, which is our equation. So that's another way to solve it. You can go in, you can make a graph, you can see where they intersect, and then that is your solution. But just a note, some lines may not intersect. If a line has the same slope as another line, then they will not intersect because they are parallel to each other. So they will never intersect. So if we get that case, then that means that they're parallel, they'll never intersect, and that there is no solution. Okay, and that is how you solve a system of equations. Now we're going to apply this to a word problem. So this can get a little tricky, but we just have to stay with it, and we just have to try and understand what we're talking about. Okay, so let's read the problem. Mike's Hard Lemonade has two different types of lemonade. There's Mike's Hard, and then there's Mike's Harder. Mike's Hard Lemonade contains 2 ounces of alcohol and 6 ounces of water in every bottle. Mike's Harder Lemonade contains 4 ounces of alcohol and 2 ounces of water in every bottle. So every week, Mike's Hard Lemonade uses 1,080 ounces of alcohol and 2,400 ounces of water. How many ounces of each liquid should be distributed amongst the bottles? Okay, so what we're going to do is we're going to first start off by making ourselves a little chart because we want to stay organized so that we know what we're saying. So first we put in our hard and our harder. We could put those in with variables. And then also we put in our alcohol and our water. Our alcohol is our X value and our water is our Y value. Okay, so now what we're going to do is we're going to take our X and our Y values and we're going to put them into this equation. So if we look at this, it says that out of the alcohol, Mike's Hard uses 2 ounces of alcohol in every bottle, so we get 2X. So X stands for the number of bottles, and the 2 is the number of ounces. And then we look at Mike's Harder, and X stands for the number of bottles, so we don't know that yet, and 4 stands for the number of ounces. So we know that 2x plus 4x equals 1080. Because if we think about it, the alcohol that's going into Mike's hard and the alcohol that's going into Mike's harder adds up to be 180. So we know this equation. Then we can actually simplify this equation, and we can add these two together, and we get 6x equals 1080. And then once we solve for that, we get x equals 180. So that's 180 bottles. Then we'll do it with water. We go down and we will take this number and this number, just as we did before, and we'll say 6y plus 2y equals, and now we're taking the number for water, so they produce 2,400 ounces of water. So we know that 6y plus 2y equals 2,400, and then we could add 6 and 2 together and get 8y, and then we could solve for x, for y, and then we find that y equals 300. So if we just want to do a little check here, we actually can take Mike's hard, the hard one, and we can check to see if these numbers make sense. So we'll take the alcohol first. So we know that Mike's hard puts 2 ounces of alcohol in every bottle. So 2 ounces times the number of bottles, which we solved up here, 180 bottles, 2 ounces times 180 bottles equals 360. Okay. Then we can do for Mike's hard, we could do the water. They put 6 ounces in every bottle, and then there's 300 bottles, so that equals 1,800. Okay, so then from there, we can do the same thing for Mike's harder. So we'll go to the harder and we'll do 4 times 180 because there's 4 ounces of alcohol, and that equals 720. And we can do 2 times 300, that equals 600. Now we can take the alcohol that we got from here, this number, 360, and we could take the alcohol that we got from here, 720, and it'll add up to be 1,080, which is the number of ounces that we found in the original equation. And we could do the same thing with water. We take the 1,800 from here and the 600 from here, and that adds up to be 2,400. And that is the number from the original equation. So we know that we did this right. So the question asks, how many ounces of each liquid should be distributed amongst the bottles? So there should be 360, 1,800, and 720, and 600. So we figured it out right, and we solved the equation. Okay, so this concludes Chapter 2. By the end of this chapter, you should be able to solve a system of equations in many different methods that we discussed. We discussed 4 of them. And you should also be able to apply the system of equations to word problems like we solved. Now we will begin with Chapter 3, and Chapter 3 is on matrices. Now we will begin in Chapter 3, and we will start learning about matrices. So, first we begin with 2 matrices of the same dimension, and we're going to learn how to add or subtract them using Excel. So, we start with this matrix, matrix X, right here, and we also have matrix Y right here. And our final product is going to go right here, where it says add X and Y. Okay, so first we're going to do addition. What we do is we notice the dimensions of this matrix and the dimensions of this matrix. They are both the same. They will always be the same if we're adding or subtracting them. So you notice that there's 2 cells down and 3 cells across. And this one is also 2 cells down, 3 cells across. So that means that our final product will be 2 cells down and 3 cells across, because the dimensions do not change when you're adding or subtracting. So we take those dimensions and we're going to highlight that set of dimensions. Okay, so we're going to take 2 cells down, 3 cells across, just like this. Okay? And then we're going to hit equal to. We're going to take the first number all the way at the top left of this matrix and the top left of this matrix, and we're going to add them. So first we do equal to, then we click on 1, we do plus, and then we click on this 7, and then we do enter, and we come up with 8. Okay, so then we are going to go all the way down to the tip of this 8 and get the little black arrow. We're going to drag this across long ways, and we're going, let me just try that one more time, and then we're going to drag it down this ways. So we dragged it across, dragging it down, and there is our final solution. So when you add this matrix and this matrix, you will come up with this matrix. Okay, now we're going to do the same thing with subtracting, so we're going to highlight our area, click equals. We're going to do it in the same spots, so we're going to click 1 minus 7, enter. We get -6. Then we're going to take this and we're going to drag it across again, and then we're going to drag it down, and that is our final matrix for subtracting. And that is how you add and subtract matrices. So now that we've added and subtracted matrices, we're going to figure out how to multiply them. So when you add and subtract matrices, the dimensions have to be the same. However, when you multiply them, they can be different. So let's look at some examples of the dimensions. In this example here, we have a 2 by 2 because it goes 2 down and then 2 across. In this example, it's a 4 by 2 because it goes 4 down and then 2 across. And then the same concept with this one. It's a 2 by 1 because it goes 2 down and 1 across. So that's how you figure out the dimensions of a matrix. So with matrices that are being multiplied, we have to first figure out what the dimension will be of the final product. So if you can multiply matrices of 2 different dimensions, there has to be a way to figure out what the dimension will be when it's all solved. So what you're going to do is you're going to take your 2 matrices and you're going to figure out their dimensions. So the row number of one matrix has to be the same as the column number of the other matrix. So I know that's a little wordy, so let's try and understand it. If we have a 2 by 3 matrix and a 3 by 4 matrix, this would work. Because if we look, we put the numbers right here, 2 by 3 and 3 by 4. These 2 middle numbers are the same. And these 2 middle numbers are what have to be the same, because we're going to wind up using these 2 end numbers. So we have to make sure that when we are multiplying matrices that these 2 middle numbers are the same. Then if we had a 1 by 2 matrix and a 2 by 6 matrix, it would work, because these 2 middle numbers are again the same. However, if we had a 2 by 3 matrix and a 4 by 6 matrix, it wouldn't work, because these 2 numbers do not match up. So once we figure out that we have the correct matrices, we have to figure out how exactly we would get the dimension of the final matrix. So what we would do is we take the 2 outside numbers and these become the dimensions. So say we have the 2 by 3 matrix and the 3 by 4 matrix. We would get rid of these 2 3's in the middle, and our final product would be a 2 by 4 matrix. Or say we have the 1 by 2 matrix and the 2 by 6 matrix. We would get rid of the 2's, and our final matrix would be a 1 by 6 matrix. So that is how you would figure out the dimensions of your final matrix. We are now going to learn about the multiplication of matrices. Since we know some of the dimensions, and we know how to find the dimensions of a matrix while you're multiplying them, here's what we're going to do. We're going to take our first matrix, which is a 3 by 3, and we're going to take our second matrix, which is a 3 by 4. We then know that when we put them together, since the 3's meet up in the middle, all that's left is a 3 and a 4 on the outside, which means that this is going to be a 3 by 4 matrix. So we're going to highlight an area that's 3 by 4, just like that. And then we're going to hit equal sign. Then we're going to hit MM, which is mult. We're going to click it. And then what we're going to do is we're going to take our first matrix, we're going to highlight it, and then we're going to hit a comma. Then we will take our second matrix and highlight it, and then we're going to close our parentheses. We're going to hit Control, Shift, and Enter. And there is our solution for multiplying a matrix. Now that we've learned how to add, subtract, and multiply a matrix, we're going to learn how to find the inverse of a matrix. So we have our matrix here, and the inverse is going to be the same dimensions as our matrix. So we're going to, we see that our matrix is a 3 by 3 matrix. So we're going to highlight an area, which is 3 by 3. So we're going to do this. Then we're going to hit equal sign again. We're going to do a capital M, and then we are going to scroll down here where it says M, and then it's inverse. We're going to hit that. Okay, and then it comes up with N inverse parenthesis. We're going to take our matrix, we're going to highlight it just like we've been doing. Okay, then we are going to close our parenthesis. We're going to say Control, Shift, and Enter. And there is our inverse for our matrix. Okay, so now we have learned how to add, subtract, multiply, and find the inverse of a matrix. And we have completed Chapter 3. We have now completed all of the chapters which I wish to cover. We covered Chapter 1, which was about linear functions. We covered Chapter 2, which was systems of equations, and we covered Chapter 3, which was mostly on matrices, and this was the goal of this video. So Math 208 is a very challenging course, but with lots of videos and reviews and a lot of practice, it's very possible to do well in this course. I enjoyed this course, and I hope that a lot of other people enjoy this course, and I hope that whoever's watching this enjoyed my video. So thanks for watching.